Two more pages left. Look at those three molecules, build them with your molecular model kits. You have the molecular model kits in the midterm exam. Prioritise the four groups which are attached to the stereocenter carbon. Prioritise them from highest to lowest, 1 to 4. And either in your mind, move the lowest priority group to the back, build the molecule and move it to the back, and look to see whether the three remaining groups go clockwise or counterclockwise around the face of the molecule. If it's clockwise, then it's the erectus, the R enantiomer. If it's counterclockwise, it's the cell S or cilia. So for that first molecule, I'm using a black bead to represent the methyl group in its entirety. I'm using a purple atom to represent the heavy hydrogen, that's a mass of 2, and a normal white bead to represent the normal mass of hydrogen. And at the top, our orange bromine atom. So as we prioritise those four groups, highest atomic number is bromine, so that would be priority 1. Then next highest atomic number is for the carbon and the methyl group, so that would be group 2. Then there's a tie for the two hydrogens with atomic number. We said if it was a tie in atomic number, we could use a greater mass. So that purple hydrogen in the front will give that third place, so fourth place to that hydrogen on the right hand side of the look at. We want the lowest priority group to be rotated around to the back of the molecule. So eclipse the hydrogen at the back, that lowest priority group, behind the stereocenter, and look at the direction the three remaining groups go. We said that the orange bromine was highest priority. Second place was for that methyl group, which is now represented by this bead on the left-hand side. So we go 1, 2, 3. We're going in a counterclockwise direction, so it must be the S enantiomer of the 2. Oops. Second one, which I've already made up as well. Okay. And this time using the purple bead for fluorine, just using one single red bead for the OH group. Oxygen is normally red. Now for the CH2CH2Cl group, I'll just use a green bead because of the chlorine on there, it's eventually in the molecule. And then for the CH2CH3 branch, just using that black bead. There's nothing wrong with making the bigger molecule, but I just get lazy, I guess. So we're looking at the priority of those four groups. Again, it's by atomic number. So we're comparing a fluorine to an oxygen to a carbon to a carbon. Ding ding ding, the winner is the fluorine with a higher atomic number than any of the other elements directly attached to the stereocenter. Second place then goes to the oxygen. We'll look at the atomic numbers, 8 compared to 9. And then third and fourth place must be for these groups here. But there's currently a tie because there's CH, CH in both of those atoms. So just at least clarify that part, first and second place. First place there, second place there. And we're going to look at those two chains. The chain sequence here, the chain sequence here. So assuming that we're starting from the stereocenter carbon, for this first chain we see a carbon and two hydrogens that are attached to it. In the second sequence, part of the sequence, is a carbon and two hydrogens, excuse me, and then the chlorine. what do we see on the other link at the molecule, the stage? So after the stereocenter carbon, we see CH2, CH3. So let's compare down the chain, atom by atom, the atomic numbers, until we find an atom on the chain of higher atomic number compared to its other chain. Of course, the first atom we saw each time was the carbon. Okay? So we can eliminate the carbon and eliminate the carbon from the search because it's a tie. We're now looking for the second atom in the chain, and we've got three choices. From here we could go up, we could go down, we could go to the right. Same here. There's three choices for the second atom in the chain. And we'll compare for the two chains the highest priority atom for each. So of the three possible atoms here, carbon's the highest priority. Of the three attachments here, carbon's the highest priority. So we're comparing carbon to carbon. It's a tie. We can eliminate that atom from the search. We're left with a second choice and a third choice of the hydrogens. The exact same atoms as we look down the chain. So we eliminate those atoms from our search. We're now looking for atoms which are 3 atoms away from the stereocenter. And again, we have 3 choices. But the best choice for this first chain is a chlorine atom. The best choice for this second chain is a hydrogen. So comparing hydrogen to chlorine, it's that chlorine-containing chain which wins the fight. So this branch is going to get 3rd place, and this is down last and 4th place. Okay, we build up the molecule again, and we'll use purple for the fluorine, a red for the oxygen, and a green for the chlorine here, and just a black bead for that one. So we want to rotate the lowest priority group to the back. So it's that black bead which is going to have to rotate to the back of the molecule. Wind it round, twist it round, and just tilt the molecule up so the black bead is right at the back. Look at the 3 remaining groups. Highest priority we said was the purple fluorine, so that's our starting points there. Second place was with the oxygen atom, and then the hydrogen. So we'll go 1, 2, 3. We're going in a clockwise direction round the face of the molecule. We should direct this to R, and then she'll know.
How are you going clockwise?
We've got a whole bunch of carbons and the hydrogen. Hydrogen is a lower atomic number, so that definitely takes last place. So we figure out what last place is first. And comparing the other 3 groups, it's carbon to carbon to carbon. Now, for the next 3 atoms we see, there's 2 hydrogens and a nitrogen in the connectivity. There's 2 hydrogens and a carbon. There's just 3 hydrogens. So the nitrogen at the next point of the chain wins over the carbon, and that carbon wins over the 3 hydrogens. So there's second place, first place, second place, third place. So when we want to rotate that molecule to put this group to the back, this group, second place, which is sticking out here, that's going to rotate around to the right-hand side as we look at it. Left-hand side as we look at it. And then the CH3 group, which is at the back, sticking at the back, is going to rotate round to the right-hand side. So we redraw the three groups attached, just rotating from that first place at the top. There's a carbon in the middle. Second place goes there. Third place goes there. As we go 1, 2, 3 around the molecule. We're again going in a counter-clockwise direction. So it's the S mentioned there.